topic is discovery of neutron. This discovery of neutron was done by the James Chadwick scientist in the year 1932, and he has bombarded a thin beryllium pile with fast moving alpha particles. These are the fast moving alpha particles are bombarded with the beryllium thin foil. During this bombardment, he has observed that another chargeless particle is evolved. This chargeless particle is represented as a 0n1, and which is also known as a neutrons, right? And the notation of this neutron is a 0n1, right? This mass of the neutron is slightly greater than there is a mass of the proton, slightly greater than the mass of the proton, right? I can write this mass of the neutron is equals to 1.675 into 10 power minus 27 kg, or in atomic mass unit also we can write 1.00 AMU. This is an atomic mass unit. So mass of the neutron is slightly greater than the mass of the proton, and mass of the neutron is 1.675 into 10 power minus 27 kg, or in atomic mass unit we will write down the 1.008666 AMU, atomic mass unit. AMU is nothing but atomic mass unit. Next topic is other particles of atom. In these other particles of atom, in addition to the electron, proton and neutron discovery, later some other scientists have discovered these other particles of an atom. So these are also present. Actually they can lifetime is very small, that's the reason within a fraction of seconds they are going to be disappear. And in that first one is a positron. So positron, actually it was discovered by the C.D. Anderson in the year 1932, and it is represented by a symbol +1 E0. And the next other particle of an atom is a neutrino, and it was discovered by the Pauling, discovered in the year 1927, and it can be represented by a symbol 0E0. And another particle is a antiproton. This antiproton was discovered by the scientist Segre in the year 1956. And other particle of an atom is a meson. Generally this meson can be represented by a symbol pi, and mainly these are three types are there. One is a positively charged meson, negatively charged meson, and a neutral meson. These charged mesons are discovered by the Yukawa theory or Yukawa scientist in the year 1935, and this neutral mesons are discovered by the Kemmer scientist. Decay is simply, it is this neutron, and decay it produces, there is an +1 P1, there is a -1 E0, which is a electron, electron is going to be produced in this one. The half-life of this particular neutron decay is nearly about 20 minutes is there. So generally neutrons are being unstable, that's the reason there is a neutron decay will takes place. Next topic is radioactivity. This radioactivity was it was discovered by the scientist Henry Becquerel in the year 1896, and radioactivity meaning is that so some of the elements which can emit the radiation on their own, such a phenomenon is it's a radioactivity, and that elements which are emitting the radiation, no, such elements are it's a radioactive elements, right? Actually this Henry Becquerel is discovered this radioactivity. It was further developed by the Marie Curie and Rutherford scientist, and some radioactive element is taken in the lead block. I am taking that uranium is one radioactive element that was placed in the lead block, and this uranium radioactive element is emitting the light, emitting the radiation. This radiation, in the direction of this radiation, there is an electric field and a magnetic field is placed, and that can be further, it can be resolved into the three directions, right? So the radiation which is moving towards the negatively charged plate, then such a radiation or such a rays are called as it's a alpha rays. Such a rays are called as it's a alpha rays. The radiation which is directing towards the positively charged plate, that is called as a beta rays. And when we are applying this electric field and a magnetic field, there is no deflection is observed in some rays that are called as a gamma rays. All alpha, beta, gamma rays characteristics was given in the one tabular form here. First here property alpha rays, beta rays, and then gamma rays. First its mass, when we will compare its mass, alpha rays are nearly having the 4 atomic mass unit, or in kilograms we can write 6.67 into 10 power minus 27, and beta rays is mass is equals to the electrons, that is 9.1 into 10 power minus 31 kg, and whereas the gamma rays are mass is negligible, right? And the next second property is charge. Generally alpha rays are doubly charged helium particle, so that its charge is a +2, whereas a beta rays is a -1, and the gamma rays do not have any charge. We can take it as a 0. Identity for the different alpha, beta, gamma rays. In the identity, helium will write down as a doubly charged helium ion, and whereas for the beta rays is which is equals to the electrons, and gamma rays are generally containing the high energy radiations, right? And the next property is velocity. The velocity of alpha rays is 1/10 of the velocity of light. This velocity of light is that is 3 into 10 power 8 meter per second, right? So in that particularly 1/10 of velocity of light it will be there. The velocity of alpha rays is equals to the 1/10 of velocity of light, whereas in the case of this beta rays and gamma rays, both are having the its velocity is equals to the its velocity of light or speed of light. And the next property is effect of electric field. When we are placing the electric field for the alpha rays and beta rays and gamma rays direction, and they are deflecting towards these alpha rays are deflecting towards the negatively charged plate, and beta rays are deflecting towards the positively charged plate, whereas the gamma rays are there is no deflection is observed and it will go straight, right? So there is a penetration power. This penetration power is nothing but it's one kind of vibrating power of the this particular alpha rays and beta rays and gamma rays, and these alpha rays are having the penetration power is small, whereas the beta rays penetration power is large, it will be there, that is nearly 100 times of alpha rays, whereas the gamma rays are its penetration power is very large, that is nearly about 10,000 times of alpha rays.